Hello, we are Group 3 with team members Arset, Attila, Jinling, Rongqing, and Yunjia. Welcome to our project presentation. The topic of our project is about predicting pet adoption speed. If you happen to work at a pet shelter, you must have noticed that due to the COVID-19 and the quarantine laws, there has been an increasing demand for pet adoption. Indeed, this is a global trend. For example, one new shelter in New York got more than 700 foster applications in 2 weeks. Pet shelters are under pressure and they need to manage inventories wisely. Our goal is to help related business understand the adopters' preferences better and make good decisions in their operations. The data we are working with is originally from petfinder.my, Malaysia's largest animal welfare platform. The data is used in an ongoing competition on Kaggle.com. We are provided with 14,993 entries of pet adoption records, which is reasonably sized. There are 23 variables about the pets, including names, color, breed, etc. And there is a variable called adoption speed, ranging from 0 to 4. The lower the adoption speed, the faster the pet was adopted. Here is a screenshot of all the data fields. We start by inspecting and exploring the data. One interesting question that people may be wondering is whether some names are more popular among the pets and could lead to faster adoption speed. We found that at least in Malaysia, Lucky is really a lucky name for dogs. Lucky seems to work well with both cats and dogs. Here are additional lists of popular names and lists of lucky names sorted by the mean of adoption speed. Pets with those lucky names can be adopted faster on average. We can see that even generalized names work well, like kitten or puppy. And baby is another lucky name for both cats and dogs. We use a logistic regression model to further inspect the data. We use the adoption speed variable as the response variable and try to find correlations. We found that among the significant variables, cats are more preferred than dogs. Female pets or gender mixed group are more preferred than male pets. Medium-sized pets tend to get adopted faster than pets of other sizes, and as expected, health of the pets play an important factor. This also includes whether the pet is sterilized and vaccinated. Healthier pets can be adopted much faster in general. Our next step is to build predictive models. Our goal is to deliver a model with high accuracy. First of all, we did some additional steps to process the data. Besides basic cleaning, we created a new variable called mixed breed to replace the original two optional breed variables. A pet is mixed if it has more than one breed. Also, we reclassified the 5-level factor adoption speed into binary format. This is because when we first tried to predict on the 5-level factor, the accuracies for the models are low. We decided that there were no strong boundaries to separate the 5 categorical levels. Adoption speed 2 means a pet was adopted within a month. Thus, we use this category as a division line so that all pets could be reclassified based on whether they were adopted within a month or not. Here is the clean data we use for predictive models, free of unnecessary variables. We built 6 models, including logistic regression, KNN, SVN, ANN, decision tree, as well as boosting and bagging for tree models. Our method is that we first build those models individually and aim for highest accuracy, and then we combine the models by building a stacked model. The stacked model is based on decision trees. We achieve a final 96% prediction accuracy with those models. If we take a closer look, the KNN model has a much higher accuracy compared to other models. The stacked model did not affect the accuracy rate, probably because there is little room for improvement. Our model can help pet shelters to optimize their resources. By predicting adoption speeds correctly, inventory turnover can be estimated in a much more accurate manner. We also recommended the shelters to focus on pets' health, which is mutually beneficial to both the shelters and the adopters. To support this presentation, we also wrote a report. Please consult the report for detailed analysis of each model. There are limitations in our work. The original data set also provided an image of the pets. We believe future research can use technologies like computer vision to find more insights. This will conclude our presentation. Thank you. We hope everyone can stay safe, stay healthy, and enjoy the time with your pets.